Okay. Hi everyone. Um, Hi everyone. I'm happy we today for us to start today's lecture. Uh, Before we start, I noticed some hands were raised up, so you can basically unmute your mic and speak if you have a question or if you have a comment. I don't know because the hands were raised up while I was trying to start the recording. So you can unmute your mic and speak. Okay, I guess that was probably a mistake. So, to start today's class, I will start as usual by asking few questions based on what we have learned from the previous class. So, can someone tell me the difference between? I think I should stop sharing the screen. I'll stop sharing the screen, then I would want to hear from this threshold. Can everyone hear me clearly?
I'm
So,
struggling to hear
do we have
you. How
anyone
you?
to answer my question? Are you saying you're not hearing me clearly?
Yes, I don't know. I think maybe it's the network or something.
Sir, it's your mic. We can't hear
Okay.
you
Yeah,
clearly.
even this side, it's very
Oh,
unclear. Not the usual mic sound.
okay. 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 So how about now? Can everyone still hear me clearly now?
Much better, much
Okay.
better. Are you?
Okay. Perfect then. Perfect then. So like I made mention of, our usual thing is to start the class by asking preview questions based on what we have discussed from the previous class. And in this case, I asked a question saying, who can differentiate between blocking sets, thresholds, and a Coulomb slice? This one I'm getting no response. Does that mean that no one remembered what was discussed from last class? Okay, Ola might please.
Okay, a column is the total node in agreement. They have to come to an agreement before a transaction can be accepted. While a blocking set are probably nodes that are not in agreement with other nodes, makes it difficult or that block other nodes from execute or from coming to a quorum. And you gave an example. For example, if node B, there's four node is added as my column, for example, and two nodes are the same, and the other two nodes are not the same. So the other two nodes are as a blocking set that's not making my nodes reach an agreement, a consensus agreement.
Thank you very much. Thank you very much for that answer. Does anyone disagree with what he has just explained? Or would anyone like to give an addition to what he has explained? Should I start calling names? Okay, great. Edrin, please. You can unmute and speak, please, Edrin.
Yes, I would like to add on what he has said. For quorum set, it's a collection of nodes that a particular node can trust for reaching its consensus. He had not mentioned the point of like the trusted nodes that a node can pick for it to reach the consensus. Then for the threshold, I think the threshold is the number of nodes that are required for a node to reach consensus. Then blocking sets, I think it's kind of a number of nodes or a combination of nodes that can prevent a node from reaching consensus.
Very good. But let me ask you a question before you mute your mic. What then is the difference between a quorum slice and a quorum itself?
Well, I would say a quorum slice is like if a node A has node B, C, and D, then the node B, C, and D is its quorum slice. Then the quorum, you asked the difference between quorum slice and quorum?
Yes.
Yes, so I would
quorum
see
itself and a quorum slice.
Well, I would call a column slice the number of nodes that make up the given node, or that allow the given node to reach consensus.
Then what is the quorum itself then? Okay, you've given a very good answer and I appreciate you for your participation. Allow other people to continue from where you stop. So thank you very much, Edrin. Divine, let's hear from you.
Okay, good evening, everyone. The quorum set is a collection of nodes that form a particular node must trust for it to reach consensus. While the quorum slice are subsets of that node within the quorum set that must agree for the consensus to be reached. So that's
Thank you
just
very
the
much.
difference.
Thank you very much. Thank you very much. Thank you so much, Edrin. Thank you, Olamite. Thank you, Divine. All of those are excellent answers showing how much we really enjoyed yesterday's class and how much we can grasp. So thank you so much, all that's answered. So we have asked questions from last class. Are there any questions you have that you do not understand a particular part from what we have discussed from last class? Is there any question, or we are good to go and then we move on from where we stopped last class? Okay. I'll take the silence as the positive answer that everyone on this call have positive understanding as to what was discussed in the last class, and so we can basically proceed. So talking more about what the quorum is, we said a full quorum is literally a set of nodes sufficient to reach an agreement across the network. It's literally the combination of all the quorum slices that collectively form a valid agreement. And then we said for the quorum slice, each of the quorum slices contribute to the overall quorum, ensuring that the consensus is reached through a decentralized process. So this is literally a recap of what everyone has made mention of from the answers you gave. Like a full quorum set is all the nodes inside of the set. All the nodes inside of the set. That is what? That is coming into agreement to make for a consensus to occur. Now, we made mention that a quorum slice is now part of those nodes that reach the threshold, which is the minimum amount of nodes required for consensus to be reached. These quorum slides are literally gotten from the full quorum set. Today, we'll be moving on to statements and node opinion. When we talk about statements and node opinion, what are we talking about? We'll be talking about what a transaction proposal is, what a valid statement is, and that's literally what a transaction proposal is. What is it? Nodes propose transaction sets for inclusion in ledger. These proposals are known as valid statements. So let's say the current block number is number 800. Now, when I'm saying block number, you have it in mind, I'm talking about the ledger, because in Stella it's called the ledger. So let's say the current ledger number is number 800. So if I propose a transaction as a validator, that transaction said to be a transaction proposal. And then all these proposals are then called statements. It's just nice to have all of this extra knowledge. At the end of the day, when you start writing your smart contract and you start deploying these smart contracts to the chain, you might necessarily not need to know or need or use all of this knowledge that we are sharing about quorum, transaction proposal, and all of this. But for you to come out as a stellar blockchain engineer, it's important that you at least understand all the infrastructure itself, what happens on the infrastructure layer. So that's why we are learning this. So node opinion is being influenced by the quorum set. When a node stands on a statement, depends on the opinions of the node in the quorum set. This decentralized process ensures that each node's opinion is influenced by its trusted peers. All of this still boils down to what we have spoken about quorum set, in the sense that for a particular node, so when a particular node makes a proposal of a transaction for it to be included in the ledger, that particular transaction, for it to be included in that ledger, all of these quorum sets literally can affect whether this transaction should truly be added to the ledger or not. This is all about talking about how really decentralized the Stellar chain is. Now, moving on to federated voting. What is federated voting? Voting is literally the normal idea of what voting is. Coming in agreement for something to happen. Whether in a layman term, you could talk about voting a president in, and then people have to, select who they want to be the president. That's just giving a normal example of what voting is. But then in this case, there are steps to how this voting is done. Because at the end of the day, we made mention that a particular threshold has to be reached for a transaction to be included. But this has to go through what we call a federated voting process. So there are 3 steps to this particular federated voting process, 3 stages to it. The first one is the vote, the second one is the accept, and the third one is the confirm. What then is the vote? In this particular case, the nodes literally initialize a vote for a transaction set. This particular note indicates that, okay, I'm willing to add this particular transaction into the ledger. So that's the first stage. So out of this particular quorum, let's go to this example. In this quorum, where we have node A quorum set, in this case, node A could be the one that says, okay, I'm interested in adding this particular transaction to the block. So that's the first step. He has to show the willingness to, add the transaction to the ledger. So that's the first step. The next step is then the accept step. What happens in this step? Once a sufficient number of nodes has voted for a transaction set, it is then accepted as a valid candidate for inclusion in the ledger. So this next step is the set where the threshold accepts or votes that this transaction so eventually, if the sets do not agree, the blocking set occurs. So these sets then form a blocking set that rejects the transaction from being accepted. So this particular quorum set come into agreement and they are like, okay, yes, this particular transaction is worthy to be included in the ledger. Then the third step happens, that is the confirm state. Finally, nodes confirm the transaction set, indicating that it is safe to act on and include in the ledger. So in this particular case, this quorum set have agreed that, okay, yes, this transaction can be added to the ledger. And so the confirm stage is literally the final stage for the transaction then to be added to the ledger. Excuse me. Node opinions. In this particular case, remember we said that a particular node could choose to do certain things. So there are different opinions a node could have. And this is what we'll be talking about next. Nodes could go through different states of opinion on a particular statement. Remember that we said a statement is literally a proposal. And what is that proposal? It's a node saying, I want this transaction to be included in the ledger. So other nodes that form this quorum set could have a contrary opinion to this. One of the opinion a node could have could be on statement A. So let's say the statement is statement A. A node could be like, I have no opinion on it. So the node is saying he is not voting for the transaction to be added or not. That is, he has no opinion on it, basically, on the statement for the inclusion of the transaction. The second state could be for a vote. You could vote for A and say valid, but not yet safe. So that means, in that particular case, the vote has been added, but it's not yet safe. So in this case, it is not yet included. Another state is the accept A, whereby that particular node already has reached the threshold. That is the minimum amount of agreement, the minimum amount of votes needed, that is to come in agreement for that particular statement to be considered for the ledger. Then the last one is confirm. And in this case, the particular transaction is now safe to be added. So at the confirm stage, we could say the statements can then be accepted into the ledger. So this is literally more like the opinion states of a particular statement. So a statement could be in a situation whereby it is valid, but it's not yet safe. That's because there's a vote, probably just one person votes for it. It could be in a next state whereby it already has reached the threshold, whereby it already has enough people that have voted for it to be included in the ledger. Then the final stage, which is confirmed, which shows that yes, this node can then be added to the ledger. Moving on. Transition rules related voting. First is consistency. Node votes for a transaction set if it is consistent with their previous votes. And this ensures that nodes do not contradict their earlier decisions. What does this mean? One of the rules is that there has to be consistency. So the nodes that vote on a transaction set must be consistent with its previous vote. So a node that votes cannot change its decision after it has voted that, oh, it's what I want to vote is for it not to be accepted. No. Let's give an example. Accept A if quorum support and if blocking set support. What does this mean? For the quorum support, every node in the quorum slice has either voted for or accepted A. And this ensures that there's sufficient agreement among the trusted nodes. Therefore, blocking set support, the blocking set has accepted A, disregarding previous contradictory votes, and then this ensures that conflicting decisions are resolved before acceptance. So that means that before acceptance stage, if you are knowing that, okay, you are not in support of this particular transaction to be added, that means you have to change your vote before it gets to the acceptance stage, because at the acceptance stage, it is ready to be confirmed. What then is confirmed? Confirm A if quorum slice acceptance. So every node in a quorum slice must have accepted A, and this indicates that the transaction set has enough support to be considered safe for the inclusion in the ledger. So going back to what we are talking about, it's still all about the idea of what happens if a person does not support a particular statement or a particular transaction to be included in the ledger. So you could initially vote A, but if it moves on to the accept stage, it's not wise to go back to, trying to change it into a different decision. So you have to be consistent with whatever decision you are making whenever you are trying to make a decision to vote in this federated voting system. Before moving on to consensus round, we've spoken much. Are there any questions based on what we have spoken, based on the transitioning rules in the federating voting system? Are there any questions? Okay, you can unmute and speak.
Yes, thank you. Really technical on that part. I was looking for as we are validator and we are supposed to run nodes. For instance, in that cases, I guess that all these steps and validation are not totally approved and done by hers, right? Is there any smart
Very
contract
correct.
behind all this? Okay, we got to set up and define all these settings you just mentioned. If I'm well, thank you.
Okay. That's actually a valid question that I really would have expected someone to ask. First of all, I want you to understand that all of these things that we are talking about has nothing to do with smart contracts. All of this happens in the Stellar core. So it really has nothing to do with you. But you are trying to understand how the consensus mechanism occur, or the idea behind the consensus mechanism that is occurring in the Stellar node. So this is more like understanding the steps as to how consensus is being achieved when it comes to the Stellar blockchain. I don't know if that makes sense to you. Okay, great. So persons that have questions. And moreover, I would emphasize it again. I've said it over and over. At the end of the day, after we finish this lecture, you might not even think about what we have just discussed again. But it is important that I include it in the lecture for you to understand how things work under the hood. Because as we progress, What we will be dealing with would be writing the Soroban smart contracts, understanding ROS, and then at that particular stage, whatever kind of implementation you want to do based on whatever application you're trying to build, based on whatever idea you are trying to build, then comes into play. But then, until that, what we do is basically understanding how the full stellar core works. And now we picked on the consensus, and then we are talking about the consensus. As time goes on, we'll still talk about other interesting things on the stellar core. But right now, it's just talking about how the federated voting system works to achieve consensus is what we are all about. So if there are no questions, I would move on to the next slide. Stages of consensus. We have nomination protocol, candidate selection. So note nominate transaction set for the ledger. This involves proposing and voting on sets of transactions to be included in the next ledger, then stopping new votes. After confirming a candidate, note stop voting for new sets by continuing existing ones. So this ensures that the consensus process converge on a single transaction set. What are we trying to say? First of all, whenever a transaction is sent, let's use the illustration of, let's say Edrin created a smart contract. Now, Edrin has created a smart contract and she wants to deploy a smart contract. So to deploy a smart contract, she sent a transaction. The first step for this transaction is it goes through a candidate selection. So the candidate selection is all about nominating which node is going to add this particular transaction. Remember we said we have so many nodes all around connected in a distributed way for it to form this blockchain. And everybody cannot just pick one transaction at a time and, whose transaction then will be added to the block at that time. So that is why this particular stage is involved. So first of all, it's true that when a transaction is sent, let's say Edrin deployed a smart contract with a transaction, and in this case, that transaction is then sent, and then in the pool, all the nodes that are willing to pick the transaction now picks it up. Now, if nodes, let's say we have node A, B, C to node F in the pool. Now, node A, B, and C picked up the transaction. So this node A, B, and C, they are the nodes that nominate the transaction set for the ledger. Then it moves on to the previous slides that we've spoken about, the voting. Now, if for node A, B, and C, remember node A, B, and C have their own quorum sets. Now, if node A quorum set has completely agreed for this particular transaction, that is, it has reached the threshold. Now, we can say it has reached acceptance. In that particular case, the remaining nodes that are now trying to create or add this transaction to the ledger are going to drop it. So what they will now do is that they are now going to support that one person that has reached consensus through his own quorum slice. So he has reached the threshold, which is the minimum amount of nodes in his own quorum slice to come to agreement. So after this has happened, so after confirming a candidate, all the nodes stop voting for the new set and they continue with the existing ones. And so this ensures that there is a convergence. There's a single transaction set. So it's not that all these people that have picked up this transaction, all these nodes that have picked up this transaction, all of them will not push it at once. So we have just one particular node that is then pushing this transaction. So what happens next? The ballot protocol. It verifies the quorum slice value readiness. Then the node prepares by ensuring that their quorum slides are ready to commit to a specific transaction set. What does committing to a specific transaction set means? This means that they ensure actual commitment of the value by the quorum slide. So let's say, for the example we have been making, node A, let's go back to the slide where we are talking about the node. Okay, so now let's say we have node A having C and D. Now let's say in this particular case, node A have reached acceptance point, and at acceptance point, node B and node C have already concluded that they are in support of this transaction to be added to the block. In this particular case, what we are trying to say is that, let me go back to it, all of these particular nodes that commit to agreeing must also commit to finalizing the inclusion in the ledger. So that means that all the nodes that are there to make up that threshold must also finalize the inclusion in the ledger. Now, I'll be very honest, these steps could seem weighing down. I mean, why all of these steps? All of these steps is basically to really reach that consensus, to ensure that the data is actually safe, to ensure that the network is actually stable, to ensure that consensus is actually truly reached. And then when finality is done, when finality is achieved, it means the transaction is then added to the block. Can I get a thumbs up if everyone understands or understood what I've just explained now? Okay, great. Okay, great. Okay, you raised your hand. Okay. So moving on. We are moving on to ledgers in the Stellar Consensus Protocol. What is a ledger? A ledger, did I see? Okay, Irene. Did I pronounce that well? I'm sorry if I didn't pronounce it well.
It's Siren, but I'm with her. I'm Joanita.
What?
We are using this. It's Irene and Joanita. We have not understood. They have shown your thumbs down. I don't know if you've seen it.
Oh, there was a thumb down for not understanding. Okay. So what part did you not
Yeah.
get from what we have discussed?
The ballot
So is there a particular
protocol.
question? The what?
I don't have a particular question. I would just like request for a pardon. If you
Okay,
can.
to re-explain what I've just explained. Does that go in line with you, Edrin? Is that also your situation? So I can reiterate it together. Okay, so let's go back. We went and started by understanding what a quorum set is. Then we said that for a quorum set to reach consensus, a particular amount of node inside that quorum set must agree, must vote for that transaction to reach consensus. Now, what we are now saying is that if for node A, which has quorum set node B, node C, and node D, are having an agreement that the transaction that is being requested to be included in the ledger coming from node A should be added by node B and node C. We are trying to say at this point that the node that supported this particular node that initiated that transaction must be ready to commit. That means they must be ready to ensure that the transaction reach finalization. Finalization is the point where the transaction is eventually added into the ledger. So that means that at that particular point, the node should not go back and now be like they are not in support of this node reaching finalization after it has reached the acceptance point, which includes the node getting up to the threshold needed for it to reach consensus. So that's to you now. That is literally what the commitment about. Does that make sense to you now, Edrin and Irene? Okay, great. I haven't heard from you, Irene. Is she there? Okay, so I'll just proceed and assume a silence means she understood. So now we are going deep down into a ledger. What is the ledger? The ledger represents the state of the stellar network at a specific point in time. And this includes all the accounts, the balances, and the transactions. What then are the components of the ledger? These are things like the accounts, the balance, the order, and the smart contract data. So a ledger has, and I'm going to show you what the ledger looks like as time goes on. So we have been talking about a transaction being added to the ledger. What then is this ledger? That's what we are trying to get at. That the ledger is literally the state of the stellar network. So when we are saying ledger, we are saying, okay, what is the current block of this network now? What is the current ledger number of this block? So the current one, where the block is at that particular point, it includes certain things, certain components like the accounts, the balances, the orders, and the smart contract data. All of this is included in the ledger. And all of this ledger is what makes up the Stellar blockchain. What is the ledger chain? It's just an historical continuity. It's just like saying blockchain. Ledger chain is just an addition of ledgers that cannot be muted based on the fact that they has been linked cryptographically. And if you can remember from our onset class, we are able to explain how a particular ledger in other chains called blocks is being linked from one to the next. And this linkage is done in a cryptographic manner. So it is done in a cryptographic manner to ensure that it is immutable and to ensure the integrity and the continuity of the transaction history. So I said I am going to show an example of what the ledger looks like. So give me a second and let me get that open. So let me stop sharing this screen and I would start sharing this one. Now, what exactly are you seeing in your screen? You are seeing what we call an explorer. It's also called a scan. A scan literally shows you what is happening on that chain currently, and you can literally track historical data using the scan. For those of us that are not running the node, if you deploy a transaction or you initiate scans for you to get the transactions. So let me ask this question before I proceed. Can anybody explain to me how this scan is being created, or what is the connection of this scan to stellar itself, based on what you have spoken about from previous classes. And if you want to create something like this, what exactly do you need to create something like this? Can anyone answer that question? Thank you, Bilwin. Let me hear it from you.
Okay, I think from previous classes, I'm not sure, but I think you said for us to connect to the Stellar network without a node, you have to use an API. Or am I correct? I'm not sure, but I remember saying you have to use either an API or then you were measuring something like RPC at some point, like something that has to join the back end stuff to the like RPC stuff or API stuff that connects it to the main code that we are writing basically.
Thank you very much. Thank you very much. Thank you very much, Belua. You made a good attempt to it. Can we hear someone else also? Does that mean no one apart from Belua remember what we discussed based on getting data from the stellar core itself? Is that what we are saying? Okay, can we hear from Olamite?
Yes, if one need to get the data, one have to have a running node, a node that could be connected.
Excellent answer. Thank you very much. That's just what I wanted to hear. For you to operate something like this, you need to have a node, because every single thing that is coming from here is coming directly from the node itself. So for you to have all of this historical data, it must mean you are connected to the node. Now, in this other sense, you can use an Horizon API to get data from the chain. But the kind of data that is being displayed here, which I would explain in a few minutes, is a full data indicating every transaction that has happened on the chain. It is indicating even previous transaction, historical transaction. And so you need to have a running node to display such a thing. So that is basically it. Thank you so much, Belue and Olamite. Thank you very much. Now, what are we talking about? All of these things you see are the ledgers. Here are the list of ledgers. And notice something. This ledger just increased by 1, and it just added to, can you see another ledger has been added to it? Can you see? Good. This literally, I'm going to open each of this ledger, and then you're going to see what are the things inside of the ledger. Inside of the ledger, we said it has the contracts, the transactions, the operations, the accounts, and the assets. So I'm going to start from the beginning, talking about what links the previous ledger to this current ledger. It's called the ledger hash. So notice that the previous hash of this ledger is this that I have highlighted. And it is basically what links this ledger to the previous one. Notice that we are on block sequence 555866898. Just put to add the 98 here. Just put to add the 98 here. And we are going to look at this previous one before this one, which is 97. And we are going to see if this particular hash matches that previous hash. So let's go back. The previous hash ends with C57. So let's go to 97. Okay. Wow. It has gone down so low. But we are going to do something. Okay. We have this block hash. 898. So we are going to do for 97. And we're going to search for it. And here we have it. So can you see? This is the previous block hash of 898, which is 897. And in this case, remember that I showed you that the ledger hash for that particular block is C57. Can you see? The ledger hash for it is what? It ends with C57. I would definitely not be calling out this whole hash out. But then what does that signify? This signifies that this hash in the next ledger, and this inclusion is what this ledger together to ensure it forms the ledger chain. And so this ledger chain literally is cryptographically hashed, in the sense that if you use as a node, if you are running a node, and then your own ledger hash for the previous one is different from what is in the current one that is being hashed together to get the next one, then there is a problem. There is a problem. So that problem would indicate that you have a malicious transaction added to the ledger. So now let's go deep down. Inside of this ledger, we can then see transaction. So all this list of transaction is what makes up the ledger. Now, one of the things we are going to talk about as time goes on is what we call operation. Now, what are these operations? I'm not going to talk about it now, as I would not want it to intrude our lecture for today. Rather, it's something I'll leave for when we are about to talk about it, because there's a whole lecture slide that has to do with operations. But then, inside of this ledger, we now have each transaction. Now, each of these transactions now have their own transaction hash. And so, if you can remember from the slide I was showing earlier, I made mention that inside of the ledger, you have certain components. What are these components? Components like accounts, balances, and what? Transactions. Transaction hash, more and more like that. And this is exactly what you can see. All of these are transactions inside of a transaction. So all of these are operations, I mean, inside of that particular transaction. And we can see the accounts that made that transaction. We can see the balance. We can see the number of transactions. And all of this is literally what we are talking about, as you can see. So that is it. Notice that everything we are talking about and everything we are illustrating, we showed it on what? On the main net. So if we could also move to the test net and also visualize what is happening on the test net. Obviously, it's going to say it didn't find this account, because what is happening? No, let me use it to ask the question. Why can it not find this account? Can someone tell me why it says it can't find this account? Okay, you can unmute and speak, please.
Yes, so they can find this account because they didn't select the testnet network to deploy it. It have been sent directly on the main one.
Excellent answer. So that means that we switched to from mainnet to testnet, and that account is not available on the testnet because the full testnet is different from the mainnet. I think someone asked this question some times ago, whether the mainnet is the same with the testnet and the future net. So we can see it's completely different. So they are completely two different things, because what is going on the mainnet is different from what's going on the testnet. There are different transactions happening simultaneously. So I am looking at the chat now, and I am saying that some people are saying they cannot see my presentation. It said, for me, I can hear what you're speaking, but not able to view the blockchain explorer. So can you view it now? Are there any persons who could not view it, but can and are still not able to view it? Okay, you can unmute and speak. Can you view it now?
Yeah, we can view it, but we missed a lot. So, because we are
Okay.
trying to figure out why we couldn't view. So.
Okay. So I'm going to go back as usual to explain the lots that you made mention that you missed. Remember, whatever goes on, it's important that you understand everything that is being discussed. So at the end, it's not for us to finish all of the slides. It's for us to ensure that we have accurate knowledge. So I started by talking about what the scan is and who can have access to everything going on top of the Stellar chain. And I mentioned that whoever is running a node can actually run an explorer. It can create an explorer because it is all about just creating an endpoint and creating visualization using UI, probably React or whatever. So create a visualization to what is happening blockchain. So in this case, we are looking at, from our lecture slide, we made mention of ledger and we made mention of the components of the ledger. So we came to the scan to look at the different ledgers, which you can see here, that makes up the chains of ledger. And then we started by explaining that a new ledger is being added every time, and the new ledger is literally having the latest ledger sequence number. So you could call it, on other chains, you could call it the current block number. In this case, is the current ledger sequence number. So inside of it, we have transactions. But before talking about this transaction, we mentioned what links a previous ledger or a previous block to the next block, and we made mention of cryptographic hashes. So this cryptographic hash of this previous block, I'm going to open it. So can you see this is block 92?
Sorry, please, we can't see your slide. Sorry, it's not showing.
You can't see my screen. I'm literally sharing.
Your slide is visible, but the wordings are very small. We can't see them clearly.
Okay, it's too small. Oh. How about now?
It's fine right now.
Okay. So that was what you were trying to get at. Okay. So now I mentioned that for each of the ledgers, they are linked together to form a chain of ledger, to form what we call blockchain. And I mentioned that these cryptographic ledgers literally hashes the previous ledger, and then this previous ledger is then included in the hash of the next ledger. So that means that for ledger 555869993, it has the previous ledger hash inside of it. And so if we click on this, we can literally come to the previous ledger hash, which ends 992. You notice that one is 993. So this is literally it, as you can see. Okay. Below, your hand is up.
Beulah, by the way. Good evening, sir.
Eh?
Beulah, not Beulah.
Oh, Beulah.
So I wanted to
Thank
ask,
you.
with with the previous hash stuff, I'm not sure, but does Della chain use this proof of work? I've forgotten it. for the consensus mechanism.
Ah,
I'm not sure. I forgot. I forgot.
yeah.
sir.
Am I meant to be happy about this question or sad about this question you've just asked?
No, the
That
main
is
question
literally
was because
disgusting.
the main reason I'm asking is because of your explanation, and I wanted to ask that because when you're talking about previous ash, and since we can see the previous ash, like for the Bitcoin now that they use proof of work, right? Is the previous ash, because I know of something that is called cryptography, right? We're talking about cryptography, that where the proof of work, where they have to work like to get the previous ash function to ensure that it fits the next block or something. So I'm not sure, since the previous is now obvious now that people can see it now. Is it that they just get to copy it without working, or like, I don't know if you get my question.
Okay.
Should
You
I
see,
come again?
I'm not happy you asked this question because you asking this question means that everything we've been discussing from the beginning of this week, which is literally yesterday, and throughout this class, you've not gotten a very good understanding to it. If blockchain literally has a consensus mechanism, now different blockchain now have their own consensus mechanism. So let me ask you, can you explain to me the difference between proof of work, proof of stake, and the federated Byzantine consensus mechanism? Can you explain the difference between these three to me?
Okay, I know I'm familiar with proof of work, proof of stake, but the last one I'm not that familiar with it. Is it possible to explain what I understand?
The last one is what we have been discussing since. Let me stop presenting
Yes.
this and present. I started by talking about what the consensus mechanism is, and I explained what the Federated Byzantine Agreement is in Stellar Consensus Protocol. That Stellar Consensus makes use of the Federated Byzantine Agreement. And then we went on to talk about how all of these nodes trust each other and how they come into agreement. And that was when we spoke about quorum set, and we spoke about threshold, blocking set, and then we spoke about how these transactions, through after hitting consensus, is being added to the block, or it's being added to the ledger. Did you get that at all? Okay. Now, to ensure that you got it, can you now explain to me what the cryptographic hash of the previous ledger that I'm showing has to do with this consensus mechanism? What do they have to do with each other? Can you explain that to me? Beulah.
I guess that was my question.
Huh?
I said, I guess that was my question. That I'm here to get it.
And now I asked if you understood, and you told me that you were giving me thumbs up. Are you
Like,
deceiving me?
I'm sorry, sir. I've already got it. I'll go through it again myself then.
Mm-mm. Mm-mm. I'm going to come back all over again. Now, I want you to understand that from our first class, I was explaining what cryptographic hashes are. And I even explained what a hash function is. Another class, I even explained the difference between encryption and hash functions. Then I went on to show visualization of different hash functions. Now, whether a blockchain is using proof of work, is using federated Byzantine agreement, is using
proof of stake or any other type of consensus mechanism. What that consensus mechanism does is just for all of the nodes participating to come into agreement for that ledger or for that block in case of other to the blocks of chain. Now, during the process of it being added to the block of chains, the ledger itself is then hashed. That is, all the transaction inside of that ledger is then hashed. And so this transaction that is being hashed has inclusion of the previous hash of the previous ledger. So that means that if you try to change a particular ledger, then it affects the next ledger. And that is where the hashing of the cryptographic hashing comes into play. So it is after consensus has been achieved that this then happens. So consensus is just the method of we ensuring that we are able to add these ledgers that I'm showing on this scan. The ledgers I was showing on that scan, what ensures us to add it, to link it up to other links or chains of ledger is consensus. But it is that linkage is now done through this hashing to ensure that this particular ledger is connected to the other one. So did you get that? Okay, great.
Yes,
In
sir,
tomorrow's class, huh?
Yes, I really do understand now. Thank you very much, sir.
So you understand now, right? Is that what you're saying? Okay, great. Now, in tomorrow's class, the first thing I'm going to ask is you explaining what I've just explained to you. So our time is fast spent, and this is where we'll be coming to the end of our class for today. I really appreciate one that made time to join this class. But before